Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in calculus. I hope that this will help you improve your thinking skills in math necessary in your engineering preparations. Explain why the function is discontinuous at a given number a. So, if you want to anticipate the answer and solutions to these exercises, you may do so by pausing the video. So for part A, when x or a is 5, we have ln of 5 minus 5, f of a, so ln of 0 is undefined. So that's the reason why, or not defined, that's the reason why the function is discontinuous at a equals 5. For part B, limit of f of x as x approaches 1. This means that 1 from the left and 1 from the right. So 1 from the left, let us say 0.99999 minus 1, the limit is negative infinity. And if we have 1 from the right, the limit is positive infinity. Negative infinity is very different from the positive infinity. So the limit does not exist. And secondly, the function value when x is 1, exactly 1 is 2 and not equal to the negative infinity or the positive infinity. So for number 2, the limit of f of x as x approaches 1 does not exist. So that's the reason, first reason. We don't need to proceed to the second one. Part C, the limit of e of x, because this is defined piecewise, e of x as x approaches 0. So from the left, let us say negative 0.00001, that's almost e to the 0, so that is 1. While the limit of f of x as x approaches 0 from the right, because we can only substitute it here, is 0. Since 1 is very far from 0, so the limit does not exist again. And second reason, even if the limit exists from the left, it is not equal to the function value when x is 0. So the limit does not exist, as I said, because when x is the limit of e of x as x approaches 0 from the left, this is 1, while the limit of f of x as x approaches 1 from the right, so 0 from the right rather, is 0.000001 square is 0, and 1 is not equal to 0, so that's why it does not exist. Limit of f of x does not exist, so that's the reason. Then third, limit of x squared minus x over x squared minus 1 as x approaches 1. So we factor out x in the numerator. So limit of quantity x times x minus 1 over x minus 1, x plus 1. We can cancel x minus 1. So that would be the limit of x over x plus 1. So when x approaches 1, this is 1 over 1 plus 1, so 1 half. The limit exists, it is equal to 1 half, but f of a, when x is 1, the function value is 1, and 1 half is the limit of f of x as x approaches 1 is not equal to f of a, which is equal to 1. So that's the reason why the function is discontinuous at x equals 1. Not equal to f of 1. So it is discontinuous at x equals 1. So given that f of x is negative 3, limit of f of x as x approaches a is negative 3, limit of g of x as x approaches a is 0, and limit of h of x as x approaches a is 8. Find the limits that exist. If the limit does not exist, explain why. So for part A, limit of f of x plus h of x, so by theorems on limits, this is just negative 3 plus 8. So for part A, it is just negative 3 plus 8, so it is 5, and it exists. Letter B, limit of f of x as x quantity f of x square as x approaches a, so it is negative 3 quantity square, and it is equal to 9. C, limit of cube root of h of x as x approaches a is cube root of 8, and cube root of 8 is 2. So the limit exists and it is equal to 2. Letter D, limit of 1 over f of x as x approaches a is 1 over negative 3, and it is negative 1/3. Letter E, limit of f of x over h of x as x approaches a is equal to negative 3 over 8, and it is negative 3/8. Letter F, limit of g of x over f of x is equal to 0 over negative 3, and 0 over negative 3 is 0, so it exists. Letter G, limit of f of x over g of x is negative 3 over 0, and remember division by 0 is not defined, so this is not defined, the limit does not exist, or because it is undefined, the limit does not exist. Then letter H, limit of 2 times f of x over h of x minus f of x is 2 times negative 3 over 8 minus quantity negative 3, so negative 6 over 11, so negative 6 over 11. And we have additional exercises here. Evaluate the limits. Limit as x approaches 4 from the left. So it is defined because 4 from the left means 3.99999, and that is square, so that's less than 16. And it is almost 16, but square root of 16 minus 16 is 0. Or we factor it into square root of 4 minus x, then quantity 4 plus x as x approaches 4 from the left. So this is approaching 8, while this one approaches 0. So 0 times 8, then square root, almost 0 times 8, square root of that is 0. So the limit is 0. Then as x approaches 2, 2 square is 4, plus 6 times 2, 12, plus 4, 16, minus 4, 12. So that means the denominator does not approach 0, so we simply substitute directly 2. So it is 2 times 2 square plus 1 over 2 square plus 6 times 2 minus 4. And that is 8 plus 1, 9. 9 over 12 is 3/4. C, as x approaches negative 2, this is almost 16. 16 plus 3 times negative 2, so 16 plus negative 6 is 10, plus 6 is 16, and square root of 16 is 4. So it's safe to substitute directly. Square root of negative 2 to the 4th plus 3 times negative 2 plus 6, that is square root of 16, and square root of 16 is 4. Then as letter D, as x approaches 2, the denominator approaches 0, but the numerator can be factored into, it also approaches 0, 2 square 4 plus 2, 6 minus 6, 0, but definitely the numerator has x minus 2 as a factor. The factors are x minus 2 and x plus 3 in the numerator. So we factor first. Limit as x approaches 2 of x minus 2, x plus 3 over x minus 2. We can cancel x minus 2, so that reduces to limit of x plus 3. Then as x approaches 2, it is 2 plus 3, and it is equal to 5. So the limit as x approaches 2 is 5. And finally, letter E, limit of x squared plus 5x plus 4 over x squared plus 3x minus 4 as x approaches negative 4. The denominator is 16 minus 12, 4 minus 4 approaching 0. The numerator is 16 minus 20, negative 4 plus 4 approaching 0 also. But x plus 4 is a common factor. So in the numerator, x plus 4, x plus 1, and in the denominator, x plus 4, x minus 1. So that will be limit of as x approaches negative 4x plus 4x plus 1 over x plus 4, x minus 1. So we can cancel x plus 4, and that reduces to limit of x plus 1 over x minus 1. Both the numerator and the denominator do not approach 0 anymore, so it is safe to substitute negative 4. So negative 4 plus 1 is negative 3 over negative 4 minus 1, negative 5. Negative 3 over negative 5 is 3/5. So that's it for this video. I hope that you learned something from this and your skills in math increases.